Physics Blender. I love 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 Physics Blender. Subscribe for more videos.
Hello everyone, welcome to Physics Blender e-learning platform. Today we are discussing dispersion paper 3 for core candidates. Let's start by question 1. Before we start, kindly check the Telegram channel to find the KWL chart to write down what do you know about dispersion, what you want to know, and at the end, what did you learn? Okay? Question number 1. Question number 1 here. In the figure, a ray of red light is shown passing through a triangular glass prism, and on the other side we have identical prism, but it is inverted upside down, this one. Okay? What do you mean by identical? It's made of the same material, which has the same refractive index, and they are identical. Okay, let's start the first part of the question. The angle of incidence of the red light at the first surface is shown as I, this one. Okay, I. Okay, on the figure, use the letter R to mark clearly the angle of refraction at the first surface. Okay, at the first surface, this surface here, this is face 1. Okay, so this is the refracted ray. So the angle of refraction is the angle between the refracted ray and the normal. This is the normal. So this is the angle of refraction. Okay, so the angle of refraction is the angle between the refracted ray and the normal. So we are done with the first part. On the figure, complete the path of the ray through the right hand prism and out into the air again. Out into the air. Label it the emergent ray. The emergent ray, and we will label it as capital R. Okay, I have to use the ruler, so I will draw here the normal to the face. Okay guys, any construction lines, we should draw them in as dotted lines. Any construction lines, we will draw them as dotted lines. So this is the first normal. Okay, how the light ray will be refracted from air to glass? It will be refracted towards the normal. So it will not continue in the same straight line like this. No, it will bend towards the normal. When it reach here, phase 2, for the second prism, I have to draw a new normal line. So to make it clear if it will bend towards or away from the normal. Okay, so here it will bend. It will not continue in this direction. It will bend away from the normal. I have to clear this. Okay. I will call it, label it line R. Okay? Okay, guys. Okay. We have here, this is the immersion tray, and we complete the path of the ray from the right hand prism and out into air. So we are done with the second part. The beam of red light is moved so that it shines into the right hand prism along the line R. So as if I moved the source of red light from here and I put the source here. So as if I have the source here, okay, is shown onto the right hand prism from line R. What will be, or mark it clearly, the point where this ray will emerge from the left. This is the left hand prism. So this is the left hand prism. So where it will appear, where it will emerge, where at the left hand prism, where it will emerge. Okay. It will follow the same path. Why? Because the two prisms are identical. They are identical. So it will emerge from this point where it originally enters the first prism. Okay, guys? Okay. I want to explain this quickly, that simply, you know, the parallel sided glass block. Okay, if you draw the parallel sided glass block, imagine it consists of two identical prisms. What happens if the light ray enters from the parallel sided glass block? So I will draw it again. I will draw it again here. As if it consists of two identical prisms. What happens? That the incident ray is refracted twice, and the emergent ray is parallel to the incident ray. The emergent ray is parallel to the incident ray. So this is what happens here. This is the incident ray, this one, and it's parallel to the emergent ray. So imagine this arrangement as if you have rectangular glass block. Also here, if the light enters from this point, from this direction, so it also will emerge from this point. Okay, simply this is just to imagine what we are talking about in this question. I'm discussing it in details because it's a classwork and it's very important. So now we are done with the third part. So on another occasion, a beam containing a mixture of red and blue is now shown into a prism. On the figure, draw the path of the blue light through the prism and out into air. So what happens here, that at the first point, at the first phase 1, red and blue, okay, they will be refracted and splitted inside the glass, and in air here they will be only refracted. Okay, so let's draw what happens, that the blue one will be refracted towards the normal also. Okay, and here it will be away from the normal. Okay, so while drawing, please take care that it will be refracted more than red, but still less than violet. Okay, so the blue one will be refracted. So this is the red light, this is red, and this is the blue. Sorry, and this will be the blue one. Okay, so it will be refracted inside the glass and in air. Okay guys, so again, drawing is very important. While you draw also, it will be important here to draw the normal line, so your answer will be so it will be refracted away from the normal. Okay, question, the next part, refraction is occurring at the first surface. Which of the following is also occurring? As we said, dispersion. Okay, so far so good.
Subscribe for more videos. I love physics splendor. I love physics splendor. I love physics splendor. I love physics splendor.